Okay, what we have here is a car starting from rest and traveling from P to Q on a straight level road where PQ is 10,000 meters. Reaches its maximum speed 25 meters per second by constant acceleration in the first 500 meters and continues at this maximum speed for the rest of the journey. A second car starting from rest and traveling from Q to P, basically the opposite direction, reaches the same maximum speed by constant acceleration in the first 250 and continues at this maximum speed for the rest of the journey. If the two cars start at the same time, after how many seconds do the two cars meet? Also find the distance travelled by each one. Okay, so what I did was I decided to draw myself a distance time diagram. Okay, car 1 and car 2. So car 1 accelerates for the first okay guys, same maximum speed. Okay, so I'm watching velocity time diagram. Ready? Velocity time. So it reaches 25, and what we can say here is that it covers 500. Okay, and then in diagram 2, this is car 1 or car A. This here is car B. And car B, we can pretty much claim the same thing. Just goes. It's a steeper incline because you accelerate to the same speed within 250 meters as opposed to 500. So it's going to be much steeper on the way up, and then it reaches 25 and goes straight across. So you can do it two ways, 25 and that's 250. Okay. Now what I did was to find the T here, I did area of a triangle. I did a half 25 times T equals 500, and then I solve for T, and then I was going to get T equals 40, and then on the other one, a half 25 times T equals 250. In this case, T equals 20. Right, so using the velocity time diagram. You could also use, did anybody else use, did anybody have a different way of doing that? UVAS. So you could do UVAST for both of them. And I liked that way because I thought it was really fast, but 0, 0, 25, 25, and then you have your S is 500, your S is 250, and you could do phi squared equals u squared plus 2as, and basically that you can find out A and then find out find out A and then find out T? Yeah. Find out A then find out T. Two-step process for that one, okay? While my way was very direct and very time efficient, okay? So what you could do is you could find out what A is by doing phi squared over 2s, and once you find out what A is, you can then go into phi equals u plus at, and then you can find out what T is once you find out what A is in the first one. But as you can see, that's a bit more time expensive than using the diagram. Is that alright? Now that we have that figured out, what we're going to do next is, we know both times, okay? So I'm actually going to write down phase 1 and phase 2 of UVAS, okay? So this is all for car A, and this is car B. Now, what I'm referring to as phase 1 and phase 2 is phase 1 is your acceleration phases in both diagrams, and phase 2 is your periods of constant velocity in both diagrams. Everybody happy with that? So there's going to be a car A, phase 1 and phase 2. Phase 1, phase 2, car B, phase 1, phase 2. So two-step process, okay? So what we have here is UVAS on both fronts. Okay, let's do this. Okay, 0, 25. I know that S equals 500. I know that T equals 40. Okay, U is 25. Phi is 25. A is 0 because there's no acceleration in that phase. S we don't know. And T I don't know just yet. Okay. Now, if the two cars start at the same time, after how many seconds do the two cars meet? Find the distance traveled by each car in that time. Okay. I think I used yeah, I know what I did. Okay. So 0, 25, A, S is 250, and T is 20. Now guys, what I'm going to do is I'm going to examine 40 seconds in. At 40 seconds in on both diagrams, are you listening? 40 seconds in diagram 1, car A has only stopped accelerating. It's now entering the constant speed. Car B, however, has reached constant velocity and continued at constant speed for 20 whole seconds. Does that make sense? 40 seconds. I'm taking it 40 seconds in. Okay? Now, in 40 seconds in, car A has travelled 400 meters, and car B has travelled 250 meters, plus it's been travelling at 25 meters a second for another 20 seconds. Means it's travelled 750 meters. Everybody happy with that? Any questions on that? Yeah. Sorry guys, car A is actually 500 meters, not 400 meters. Excuse me. So, car A has travelled 500 meters and car B has travelled 750 meters total. Is that alright? Now, we're at the stage 40 seconds in. One of them is travelling 25 to the car A is travelling 25 to the right, and car B is travelling 25 to the left. Is everybody happy with that? How much distance is in between them? Well, there was 10,000 meters at the start of the question. However, we've eked away 500 meters covered by car A and the 750 meters covered by car B. That leaves you a grand total of up to 8,750 meters left over. So 8,750 meters between both cars at this point in time. So at the point where they're both travelling at constant velocity, they're both 8,750 meters apart. Now we can do a trick, we can do a relative velocity trick if you want. Everybody know what the relative velocity trick is? They're both coming towards each other at 25. Yeah? So if I fix car B in position and I pretend that car B isn't even moving, how far is car A going relative to it? If they're both coming towards each other at 25 meters per second, what's an equivalent speed if car B wasn't moving at all? 50. So we're basically going to change it to A is moving 50, B is stuck to the spot, and you have to cover 8,750. 8,750 is your distance, your speed is 50, 8,750 divided by 50? 175. Did anybody do it that way? Yeah? Good. 175 seconds. Short and sweet. Okay? There are other ways of doing it, but that's the most direct, fast way of getting it done. Now, part B.
Do you not have to add 40 seconds on the word there?
You do indeed. So we covered it took 175 seconds traveling at constant velocity, but we forgot that that was 40 seconds in, which makes a grand total of 215 seconds till they both collide with each other. Everybody happy enough with that? Now, what we're going to do next is I don't think we use any. I didn't need the acceleration for that question, but some people can get the acceleration and work it out a different way. Takes longer though. If the start of one car is delayed so that they meet each other exactly halfway between P and Q, find which car is delayed and by how many seconds. So one of them's going to get delayed. Which one do you think has to be the delayed one?
B.
Car B has to be the delayed one. Why is it car B?
So it's a shorter,
Sorry?
it's a quicker acceleration.
Quicker acceleration, okay? Now, we're going to make the assumption that although it is delayed, they're still going to cover their 250 meters and their 500 meters before they meet each other halfway. They have to. Okay? So they're now meeting each other halfway. So we have here is so A and B and the midpoint in the middle, and that is each one is covering 5,000 meters. Everybody cool with that? Okay. And we know that car B is delayed by t seconds. Where we don't know how long it's been delayed by, okay? Now, how long does it take each car to get to 5,000 meters is what we should be trying to figure out. How long does it take each car to get to 5,000 meters? Let's say with no delay. Just say like 5,000 meters normally, how long will each car take? Okay, so 5,000 meters is the goal. Let's figure out how to work out car A. Well, car A, it travels 500 meters and it does that in how long? 40 seconds. Car B, it's 500 meters in, was it 20 seconds? Oh, sorry, 250 meters in 20 seconds. Okay, now let's add on the rest. You've travelled 500 meters. You were meant to travel 5,000. Means you have 4,500 meters left. Using distance over speed, we can find the time. Distance over speed is 4,500 divided by 25, and that will come out to be 220 seconds. Everybody happy with that? 220 seconds. Second one, our 4,750 meters left over because we travelled 250 meters already. Using distance over speed, we get our 4,750. We divide it by 25, and that comes out to be, anybody? 210 seconds. What we have there is a discrepancy of 10 seconds for car B. Car B does it 10 seconds quicker. Therefore, car B needs to be delayed by 10 seconds. Is that right, guys? There we go.